Hi everyone. So today I would like to introduce you guys about our topic which is logical equivalence. So, logical equivalence is a fundamental concept in propositional logic that describes the relationship between two statements that always share the same truth value. Two statements are said to be logically equivalent if they produce identical result under all possible truth conditions. This relationship can be verified using truth table where corresponding truth values of the statement are compared or by showing that the biconditional of two statements is a tautology. In conditional statement, logical equivalence also involves the concept of the converse, inverse, and contrapositive. Among these forms, the contrapositive is logically equivalent to the original statement, while the converse and inverse are logically equivalent to each other but not necessarily equivalent to the original statement. Understanding this relationship is essential for analyzing conditional statement, simplifying logically expressions, and constructing valid logical arguments in mathematics and related fields.
To better understand the concept of the logical equivalent, several important points need to be discussed. The following content explains of what is the logical equivalent is, how it is represented, and how truth tables are used to determine whether two statements are logically equivalent. First of all, logical equivalence is about two statements that always have the same truth value in every situation. Mathematically, it can be expressed between two statements P and Q by writing PQ, which means P and Q is logically equivalent, where the is the notation for logical equivalent. Statement P and its double negation are the simple illustration of two statements that are logically equal. If P is true, then its double negation is also true. Logically equivalence can involve conditional statements and biconditional statements. Truth table can be used to evaluate logical expression such as conditional and biconditional statements. Truth table are a tool that can be used to demonstrate whether the statements are logically identical. When the two assertions, truth value, conditional or the biconditional statements is tautology, they are logically equivalent. First, I will show you the truth table for conditional statements. For this truth table, it shows the relationship between two statements, which is P and Q, in the form of a conditional statement. P implies Q. In the table, we can compare the column for P implies Q with the column for not P or Q. We can see that the truth table value is in both columns are identical for every possible combination of P and Q. Therefore, we conclude that P implies Q is logically equivalent to not P or Q. This means that both statements always have the same truth value in every situation. Secondly, I will show you the truth table for biconditional statements. In this table, we form a biconditional statement written as P implies to Q if only if not P or Q by comparing the two statements from the previous truth table. After filling in all possible truth values for P and Q, we observe that the final column contains only one true value. This shows that a biconditional statement is a tautology, meaning it is always true in every case. Therefore, we can conclude that the two statements are logically equivalent because their biconditional statements is always true.
First of all, I would like to talk about converse. Converse is reversing the hypothesis and conclusion. Given an original statement, if P then Q, then the converse statement will be if Q then P. The first question that we got is, does the converse have the same truth? The answer is no. I will give you guys an example. For statement P, we got is a goat, and for statement Q is an animal. For the original statement will be if it's a goat, then it's an animal. This statement is true because all goats are animals. For the converse statement is if it's an animal, then it's a goat. This statement is false because not all animal is a goat. I will give you guys a proof with truth table. For the first column, we got true, true, false, false. And for the second column, we got true, false, true, false. For the third column, we got true, false, true, true. And the last column, we got true, true, false, true. Okay. The last two columns show that the converse does not always share the same truth value as the original statement, so it is not logically equivalent to the original statement. Okay, for example 1, the original statement given, if I study hard, then I will pass the exam. For P, we got I study hard, and Q, I will pass the exam. So, the conditional statement will be if P then Q. Then the converse statement will be if Q then P. Therefore, the converse statement is translated as if I pass the exam, then I study hard. So, next we will see the example 2, which is the original statement given is if I am hungry, then I will buy food at the food stall. So, we can see that P is I am hungry and Q is I will buy food at the food stall. For the conditional statement will be if P then Q, then the converse statement is if Q then P. Therefore, the converse statement is translated as if I buy food at the food stall, then I am hungry. Alright, so this is the last example for converse. Given the original statement is if I work extra hours, then I get extra income. So for P, we got I work extra hours, and Q, I get extra income. So as we know, the conditional statement will be if P then Q, and the converse statement will be if Q then P. Therefore, the converse statement is translated as if I get extra income, then I work extra hours.
Next, I'll explain to you about the contrapositive. Contrapositive is both reversing and negating the hypothesis and conclusion. Given an original statement, if P then Q, the contrapositive will be if not P then not Q. Here are some simple examples to show that the statement and its contrapositive are logically equivalent. First of all, given P, the box has a blue ball, and Q, it has a red ball. Original statement is if P then Q will be if the box has a blue ball, then it has a red ball. This statement is true, and the contrapositive will be if not Q, then not P. If the box does not have red ball, then it does not have a blue ball. This statement is also true. Based on the truth table given, we can see that if P then Q and if not Q then not P are the logically equivalent statement because they have the same true value. Okay, here are some examples to explain more about the contrapositive. For the example 1, the original statement is if I study hard, then I will pass the exam. P is I study hard, and Q is I will pass the exam. So conditional statement is if P then Q. Contrapositive statement is if not Q then not P. Therefore, the contrapositive statement is translated as if I didn't pass the exam, then I didn't study hard. Example 2. Given the original statement, if it is raining today, then I will not go to school. So P will be, it is raining today, and Q will be, I will not go to school. So the conditional statement will be, if P then Q, and the contrapositive statement will be, if not Q then not P. Therefore, the contrapositive statement is translated as, if I go to school, then it is sunny today. Example 3. Given an original statement, if Ida likes reading, then she likes watching movies. P will be Ida likes reading. Q will be she likes watching movies. So the conditional statement will be if P then Q. And the contrapositive statement will be if not Q then not P. Therefore, the contrapositive statement is translated as if Ida didn't like watching movies, then she didn't like reading.
Lastly, I will explain about inverse statement. The inverse of a conditional statement is formed by negating both hypothesis, and the conclusion is actually the converse of the contrapositive. It is represented in the form if not P, then not Q for a conditional statement, if P, then Q. Understanding the inverse is crucial in exploring logical implications, as it helps in evaluating the true value and relationship between propositions. First, I will give a simple example. Given a conditional statement, if P, then Q. So, the inverse of this statement is if not P, then not Q. So now I will explain to you how to determine whether the statement is logically equivalent or not equivalent. For this example, we have the P is it is not raining and Q is the grass is wet. For the original statement, it will be if P then Q, which is if it is raining, then the grass is wet. This statement is true. And for the inverse statement, it will be if not P, then not Q, which is if it is not raining, then the grass is not wet. The inverse is false only when not P is true and not Q is false because the grass can still be wet for other reasons. This shows that the inverse does not always share the same truth value as the original statement. So, it is not logically equivalent to the original condition. Now, I am going to teach you how to translate an original statement into an inverse statement. For example 1, we are given a statement which is, if I am hungry, then I will go out. We need to identify which is P and which is Q. For P, we have I am hungry, and Q, I will go out. The conditional statement will be if P, then Q. And for the inverse statement, it will be if not P, then not Q, which is if I am not hungry, then I will not go out. For example 2, we are given a statement which is if I am happy today, then I will go cycling. The P is I am happy today and Q is I will go cycling. The inverse statement will be if I am not happy today, then I will not go cycling, which is if not P, then not Q. And for the last example, the statement given is if I finish studying, then I will go to the party. We need to identify the P and the Q, which is P is I finish studying and Q, I will go to the party. The inverse statement will be if not P, then not Q, which is will be if I didn't finish studying, then I will not go to the party. Finally, for conclusion, logical equivalence occurs when two statements have identical truth value in all cases, which can be verifiable via truth table or tautologies. conditional statements and their related forms, which is converse, contrapositive, and inverse, illustrate important logical relationship. The contrapositive, which reverse and negates both parts of the original statement, is always logically equivalent to the original statement. The converse and the inverse are not logically equivalent to the original statement, although they are logically equivalent to each other. Understanding these forms and their truth value ensures accurate reasoning and interpretation of logical statements.